Hello, Dr. Fawkes here. Going to have a little chat about P1, Unit P1, keeping homes warm. So, typical introduction question might be something like, where could you reduce heat loss from this building? So we would highlight maybe, let's say 4 areas. 1, 2, 3, 4. Now what we're going to say is, to reduce heat loss at the windows, we could use double glazing, 2 layers of glass rather than 1. That's a very popular one. Roof insulation up here. Oh. Roof insulation. So it's like stuff like fiberglass. There, we could have draft excluders. Around the door frame, and another big one, cavity wall insulation. Now, when we talk about insulation, we're talking about reducing heat loss by radiation, convection and conduction, and you might need to explain those. Now, this is a thermal image, an image of infrared radiation, and if we look at the scale here, we can see that the higher temperatures are the lighter colours, lower temperatures darker. So clearly window is the main place where heat is being lost. Is this a door frame there possibly? So, or there. So a little bit of heat lost at the door, but the main loss is at the window. And the way we reduce insulation, or we reduce heat loss through insulation, is usually to provide something to stop radiation, convection or conduction. So here we've got a typical brick wall in 2 layers, and we've got this gap in between. Now bricks actually conduct heat reasonably well. So heat will be conducted there, and heat from there will be conducted across the brickwork, but you don't get very much conduction across the air because air is a very poor conductor of heat. However, you will get convection currents circulating air in that gap. So to reduce convection currents, what you do is you put polystyrene beads that reduces the airflow and reduces heat loss by convection. It's the same thing in double glazing. Glass is a reasonable conductor of heat. Heat one side of the glass and it will heat the other side, and the same here, but not in the gap. But you will get convection currents set up in the glass, in the air between the glass, and that can allow heat to transfer across. But what you could do is you can have a vacuum between the glass layers, and that means there will be no conduction at all, and the only heat loss will be through direct radiation of heat. And the glass is fairly good at reflecting infrared radiation back into the room, so you don't lose heat that way. Then if we have a quick look at roof insulation, fiberglass, just to clarify, there's a microscopic picture here, and it's the big air spaces between the fibres of glass. That's where the insulation is. The glass itself conducts, but all the air spaces reduce conduction. So finally, you might get a question that says, what is the payback time of lost insulation like that? It says cost of lost insulation is £200, saves £68 per year. What's the payback time? So we just do a calculation, which is to do £200 divided by £68 saving a year, and 2.94. So payback time will be 2.94 years. So you get your money back within 3 years.